In this video, I'm going to go through some of the mechanics of working with Jupyter Notebooks to draw some graphs and use some of the files you'll download from MEC 217. Start by running Anaconda, which I hope you've already installed. Launch Jupyter Notebook. And it'll open a browser window that points into your own home directory. So if we look at my Finder on the Mac and compare these, under Selens-R, Anaconda, Anaconda Applications, Applications. This is just a view into my file system. So I can go and look at what's on my desktop by clicking on that desktop, and it tells me there's a bunch of files on my desktop. There's a test Python notebook there, and there's a folder called Rick's Examples. So I'm going to go to Rick's Examples, and we see that it's empty. In the examples, I could create a new Python 3 notebook. And in that notebook, I could start putting some Python code. I could start with something really simple like x equals 5. And then print x. And I could run that. But if I wanted, and it prints out 5. If I wanted to do something more interesting, I'd need to make an array maybe. So I could make y into an array. And I've seen before that there's some functions from NumPy, and it usually is like np.zeros to make maybe an array of 10 zeros. So if I run that, I get an error. What have I forgotten? At this point, we probably want to go back and look at some of the resources from the OnQ website. So let's go back to OnQ. Oh, shrink that down to a visible size. And check out what's going on MEC 217. If I go to the content, then if I follow all the way down to this resources section, there's something called Python code fragments. And if I select that, then I've got a variety of examples here. Let's take that one. The only thing I can do with it in OnQ is download it. And when it downloads, I could try opening it, but it's told me there's no application that will let me do anything with that. And you'll run into the same problem in Windows. So I'm going to cancel that. And I'll see if I can find something to do with it. Where did it go? Probably went to my downloads folder. So if I look at home, downloads, sure enough, there it is. I can open that up and see what's in it. And in that example, it had this line where it was importing that library that we're going to need if we want to do any of the array stuff. So that NumPy library, I'm going to copy that and paste it into my function over here, my notebook. And let's try running this cell again. It still does exactly what we expected it to do. But now if I go and run that cell, no error this time. That's because we've imported this NumPy library as NP. So when I say that I want y to be 10 zeros, I actually can find the function that lets me do that. So let's print y. And run that. Oh, I should have had parentheses. Okay, now I've got y equal to 10 zeros in the box there. That's good. I could set some of the values of y. For instance, I could make y4 equal to 27. And then I could, shorthand for print y is just, I can put y in there. And sure enough, I set the fifth element to the value 27. 0, 1, 2, 3, 4 are the indices that go along with it. Before we go too far, let's make sure that we've saved our work. This thing's still called untitled. So let's give it a name. We can call it test 1. And so I've renamed the file test 1. And if I want to make sure that it's still there when I go looking for it later, I'm going to have to save and checkpoint that file just so that it's always there for me to go back to at that state in the workspace. So it's created a checkpoint, which means I could go back to the same values in the calculation as well. So that wasn't very interesting. Let's try something a little more interesting. Instead, let's make x equal to something that's spread linearly, and that's a linear space. That's another function from NumPy. And we'd like it to go, say, from 0 up to 10 in 8 steps. If I run that, I get another one of those errors. Linspace is not defined. I have to tell it that I want it to be the linspace from NumPy that I imported. And now it works. And if I print out whatever's in X, 0, 1.42, 2.8, 4.28, and so on up to 10. So I've got 8 values there, evenly spaced up to 10. I could then say y is equal to x squared, and what does y look like? It ought to go up to 100, right? And sure enough, it does. So if I wanted to draw a graph of those two arrays of values, I could plot x and y against each other. And if I run that, I get that name error again. If we go back and look at the example from the resources, oh, there's this plot thing going on here. So I better make sure I've got those functions. And if I put that back in up here, so that I've got that as well, and I'm going to put it at the top so that it's always there. Then I'll run all of these over again. And I still got an error. When I imported it, I imported this matplotlib pyplot library as PLT, so I've still got to have that PLT prefix. So plt.plot, make sure that I get that plot function from matplotlib. And this time, oh, I didn't get anything. It didn't show up. Where did it go? One more little detail. That line there, that tells it to put it right inside the notebook when it does the plot. So there we go. There's a plot of y equals x squared. So we've succeeded in plotting a graph. Now you're going to make mistakes like this all through the term. You're going to have to go back and troubleshoot them and figure out what's going on. It's going to help a lot to look back at some of these examples. Now, suppose I wanted to put some labels on the axis of that plot, or give it a legend or something. I would have to find out some more about how to do that. I could go to the example, or I could try searching. Python plot axis label. pyplot tutorial. Plot y label some numbers. Okay, so let's go back and try that. Plot.ylabel, and I'm going to actually give that a string. This is the x value squared. If I run that, oh, now I've got a label on there. And I'm betting that I could do the same thing to get an x label. So this is the x value. I like it better capitalized. And when I run that, I get the x value there and the x value squared on that axis. And there are all sorts of functions like this. The best place to get them is from these tutorials. So matplotlib.org has a huge collection of information for you, and you can find it usually just by Googling what you wanted to know. For instance, Python, well, I'm looking to put a legend on my graph. Well, didn't even need to say I was trying to do a plot, just the legend guide. You can go and find out some more about that and how to put a legend on. But we're going to put a plot legend. It's going to plot with the labels. So try that out and see if you can make a legend on your graph here and see what comes out.